Hi, everybody. I'm Tony Yee at Show IP Interface Brief, and today is day 25, everybody. This is a big day. It is 25% of the way through our 100 days of labbing. We are 25% closer to our destination. It's actually kind of scary. I was kind of thinking about it before I came home this evening, thinking that what am I going to do today? Not thinking that it was my 25th day, and then realizing that today is my 25th day, and it is really frightening to know that 1/4 of my time is gone already. And I try to look back at, have I accomplished enough? Have I done enough? Have I spent my time wisely? I don't know the answers to that, the correct answers to that. But I can tell you I've had a lot of fun. I've learned a lot, and I'm really happy I took the time to do this journey, this 100 days journey. And I definitely don't feel like my time has been wasted. I don't know if I've spent it 100% efficiently, but I don't think my time has been wasted. So I'm really happy about that. I'm really happy about the things that I've learned along the way. Gosh, you know what actually I should do? I wish I had I'm looking around like I have a list somewhere. I should make a list of the things that I've accomplished in the past 25 days. I mean, a couple of the big ticket items was I did a lot of work with DMVPN in tons of architectures, with tons of protocols, with IPv6, with IPv4, with all kinds of stuff. I did a pretty good deep dive on OSPF authentication specifically, and that's because that was just a little confusing for me because there are so many different ways to accomplish something. Let me see if I can get this off my screen. Deep dive on OSPF. I've done a deep dive on HSRP and VRRP, although I haven't done that recently. Actually, I haven't done that as part of my 25 days. I did that before my 25 days, so I can't count that, or before my 100 days of labbing. I've done 2 foundation labs so far on the INE workbook. That is really cool. I've read a good amount of books for study. All around, it's been a good experience. So I definitely haven't wasted my time. I probably could have been more efficient, and I hope that as we progress through this journey, we will become more and more and more efficient. I say we because I know there are some of you that are out there labbing along with me and doing this journey with me and taking it seriously as well. So make sure you give yourselves a big round of applause for all the hard work that you put in consistently. For anyone out there who's labbing, who's putting in the time. Okay, so where am I at? Where are my studies at? What was I doing today? Today I was continuing with walking the OSPF database. Now, I'm not going to do that live here like I did yesterday. Yesterday I did a live lab, which I thought was pretty good. They say one of the best ways to learn something or to make sure that you understand something fully is to teach it to somebody else. And I don't think I'm 100% there yet. But I'm on the right path to understanding all the nooks and crannies. I'm not there yet, but I'm getting closer, and that's the whole point of this. We just chisel away at it a little bit every time. So I didn't feel like building my own lab tonight. Recently I had gotten Nick Russo's OSPF troubleshooting lab, or troubleshooting OSPF lab, from his Cisco Live presentation, which I was there with the LAN Tamer and a couple other folks from our Discord server, and I guess a friend of his, and also someone that I see over in the Network Collective Slack. I don't know his name if I'm saying it properly, but Stein. He went ahead and made the topology in EVE-NG using IOL images, and I downloaded it, and I just kind of kept it because there are 19 routers on this topology. I really wasn't sure how it was going to work. So, and I didn't think I was ready to actually solve the troubleshooting problems that are in the topology. So this topology is 19 routers. In fact, I'll just show you. This is the topology. Now, I actually have a picture a colorized picture somewhere. I swear I have it. Of the topology. This was handed out at the conference. It was on everybody's, all the seats when you came in, so I kept that. And but this is what it looks like in EVE-NG. So it follows the similar flow, looks identical there, but we don't have the colorized areas. And so what I did today was I just kind of went around to each router and loaded a console, and then I minimized this whole screen. And so that left me with 19 console screens open, which was really cool. So I didn't actually look at this topology at all during walking the OSPF database exercise. And I did that just to kind of force myself to hide it from myself, because I have a tendency of looking at something and having a pretty good memory about how things are generally laid out. So I didn't want to cheat the system. So I went ahead and just started, and if you guys want to see the topology or the place to get it, I think I put a link in the description, and here is the GitHub here. Again, this is the information here. Here's the image for the topology, so you guys can grab that as well. Anyone who wants to go ahead and lab this up. It's a really great lab, really good deep dive in OSPF. And I tell you what, I'm honestly a little bit scared to complete the troubleshooting parts of it because there were so many things I didn't know at the conference during the session. So I feel like I still have, it is a large uphill battle or a large hill to climb still in front of me. But that's okay, I'll get there. I'm not afraid, I'll get there, it's just gonna take time. So today I went ahead and just walked this topology, walked the OSPF database of this topology. And so I showed you what the topology looks like in EVE-NG and the printout. And this is what my paper copy looks like. So that is one half of the sheet. Here's another sheet. And then it bleeds over into a sheet number 3. So it kind of took up more than one piece of paper. I realized that it is very sloppy and almost nobody else could understand it but myself. But what was really cool was, I don't know how long this took me. It actually took me quite a while, maybe an hour, hour and a half, maybe 2 hours. I really wasn't watching the clock. I had some music playing in the background and I was just jamming right along. But what I realized here is some of the things here in the drawing, in my drawing, my pencil drawing, or it's a pen drawing, I found that were links that maybe weren't connected to something or something that wasn't connected. For example, there's routers 9, 10, and 11 that actually in the OSPF database, they're kind of off on an island. They're not joined to the rest of the OSPF domain. I assume they would join through router 8. And so I assume that is one of the faults. That is one of the things, the troubleshooting things that you have to repair, is actually fixing some of the OSPF adjacencies. I haven't gone through the GitHub, but there are the problems here. I don't know if it's the troubleshooting, initial, reference material, reference topology, initial configs. I guess so. Here are some of the problems to solve. I guess that's some, probably not all of the problems. Anyhow, after I did this, I realized that I had a disconnected group of routers that weren't in the OSPF domain, and OSPF I don't think was running on router 8. I don't know if the configs were there. Actually, I didn't check the initial configs. Here they are right here. You could probably look. I don't see OSPF in there. I see EIGRP. I see EIGRP. So it looks like this was probably a redistribution point. Again, I didn't work through all of the problems solving the topology. This was an exercise for me personally to walk the database. And that's what I'm calling it. So I'm calling this walking the OSPF database. That's what I've been doing for a couple of days. I started one of those couple of routers, just like 2 or 3 routers, and I call the string of pearls, where it's just a router connected to a router connected to a router. And I did that. I built the topology yesterday, which was of my own design, and then I didn't want to build a topology today, so I just fired up Nick Russo's topology, and just walked through it. And it was a little overwhelming. It really was. And I'm not sure if I did it the right way. And what I mean is, I'm not sure if my methodology of walking through the OSPF database is the correct way to do it or even the most efficient. But I did get through it. I did get all of the, I think, pertinent information, which was all of the IP address on every segment from the routers. And again, I'm using only the OSPF database. I'm not using show IP interface brief. I'm not using show run. I didn't use show IP protocols, and I didn't use show IP OSPF. I'm using only the database to try and derive the logical topology from that. And so afterwards, it was really exciting. So however long it took me, maybe 2 hours, I went ahead and pulled up the EVE-NG topology on my screen, and I had my piece of papers here, and I started with routers 12 and 13, and I just followed my logical path, and it matched up. Boom. Perfect. Again, there was a couple of disconnected areas. I made a boo-boo on this piece of paper where I drew one router as two separate routers. That was just, this is sloppily drawn. But I was happy to know that my interpretation of the OSPF database was accurate, and I was able to recreate a topology. That's really cool. That is something that I couldn't do a week ago, or would have taken me nearly all day. And although this might have been taken longer than it should, this is a step in the right direction. So if I can tune this ability down, then this is what I'm talking about, solidifying the foundations. This is what I'm talking about. If I can tune this down to make this sort of become muscle memory, and a little bit just projection, to where I can look at a topology and sort of project or understand, project in my mind what the database should look like based on a topology. So there were a couple of neat things in here, and again, I didn't solve all the troubleshooting problems, but where there is a DMVPN, that was a little interesting to see in the database, because the link costs were 0, and how the links were identified and shown in the database was a little unique and a little different than the rest of the topologies. So that's something I need to do a second look at, and to better understand what the DMVPN, I guess, tunnels, what that looks like in the OSPF database, because it was represented a little differently, and actually that gave me a moment of pause. I wasn't really sure what I was looking at, and I had to cross a couple of things out because I was wrong, and I was just looking at it incorrectly. Yeah, so I kind of ended up drawing myself into a circle where links that should have been joined to other routers, I drew them facing the inside of a circle, so I couldn't. So I just kind of had to use my imagination to get through there. But it was really cool to be able to do that. So I'm going to continue to become more efficient at this, and I'm really looking forward to it. So this is not going to be the last time that I touch this topology. I'm actually going to circle back around, maybe not tomorrow, but circle back around and actually start working on troubleshooting this topology probably soon. Not immediately, but probably soon. I will circle back around, and actually I think I might do like a Saturday stream. You know, I do my long streams on Saturday, which are normally 6 or 7 hours. I might do this as one of those labs that I do on a Saturday, because I assume it's probably going to take me a long time. So I want to make sure I give myself lots of time, because it is nearly 11:30 already, and I don't want to be working on a topology till 2 or 3 in the morning, because I have this terrible problem. And some of you network engineers, guys and gals out there, will understand, like, I can't walk away from a problem unsolved. In fact, if you go back and watch some of my very early streams of like day 1 through 7, there was one time where I actually had to just stop the video. I was doing something live, and I said, I just can't solve this, and I'm just going to shut the video and do some research and see if I can fix it. And then the next clip, I turn the video back on, and I go, I just sat here for 5 minutes, I thought about it, I figured it out. But I can't let things go. I can't let them go, and I don't want that to happen here. I want to make sure I have lots of time and I'm not pressured to get it done. Okay, so that is Nick Russo's troubleshooting OSPF from the Cisco Live session as the topology was built by Stein or Steen. And thank you very much to the both of you. Nick Russo gave an awesome presentation. I think anyone who has talked about it has given nothing but positive raving reviews. It really was a great session, and I think all of us learned a lot. And I think it really set the high watermark on what the depth of OSPF knowledge can be, right? It's a lot more than what I'm doing right now, which is just walking the OSPF database. There's a lot more finer bits to understand. I'm not quite there yet. I'll get there. But thank you, Nick, for sort of setting the bar very high. It gives all of us, something to work hard for, something to shoot for and to aim high. And so thanks a lot. I really do appreciate it. A side note about this, I actually gave myself a couple of talking points to talk about tonight. The second bullet point here that I want to talk about is actually the topology itself. So aside from Nick Russo's great session and everything, this topology, I'm going to bring it up here, is 19 routers. It's 19 freaking routers. And I'm running it on a little tiny VM on an old PC. All right, actually, I think I'm going to do a vlog one day, which is a breakdown of all of my equipment and everything that I do, because I sometimes, I did a vlog the other day about someone was asking about what kind of hardware to buy, and I said, don't buy hardware, just go virtual. And so people were, are like, well, I'm going to buy a server, I'm going to buy a Dell, R710 or something. I mean, you don't need that. I'm running a little old PC downstairs with 16 gigs of RAM and a Core i3 processor, and the reason it has 16 gigs of RAM is because I'm running like 10 other VMs on it. This VM doesn't have that much resources, and I'm running 19 routers. And why this is so amazing is if I go over here to the status window, click status, this is showing I'm only using 5% of my CPU. Now, typically when you start a virtual router or a virtual switch in any environment, that boot sequence actually will spike the CPU. Anyone who's worked in GNS3, you have to like run, if you're running a Dynamips image, you have to create the idle PC value, and it will spike for a while, and then it will settle down into the idle value. These images, this topology was built on the IOL images. I'm running 19 of them here. You can see in the middle of the screen, and the CPU usage rate here at 5%. It's blowing my mind. It's so small. Unbelievable. And this is blowing my mind because the topologies that I've been working on and building myself and replicating in EVE-NG, I've mostly been using the VIOS topology. In fact, the INE workbook topology that I use is a VIOS topology. And when you boot a VIOS router, that CPU, this same machine that I'm on, just one router will spike the CPU 100%. We'll peg it at 99% until that router calms down. And it's not about, I'm not running a Dynamips image, it's VIOS or IOS-V, and it'll settle down after it boots. But that means even on the INE topology, which is only 14 devices, right? It's 10 routers and 4 switches. Is 14 devices, you have to start them in sort of like groups of 3. Now, if you have a very robust server, you can just go ahead and just maybe highlight all and start. I don't recommend it. I recommend doing groups, so you can do groups of 3 or 4. And it'll just peg your CPU for a little while. About a minute later, it'll calm down, and then you launch the other 3 or 4. All right, so there's your EVE-NG tip for the day. In fact, that tip is in EVE-NG's cookbook. If we go EVE-NG cookbook, PDF, this is from their website, and this is their PDF. Guys, I've been referencing this cookbook a lot lately. Anytime I have a question about something in EVE-NG, it's in this book. It's almost guaranteed to be in this book. Although if there's anything that's even like strange behavior, or you want to find out how to do something, it is likely in this book. How to run EVE on all these different platforms and everything. I really like this platform. I think it's really great. And even it talks about starting images. It says start them in groups. Start them in small groups. That's their, I guess, official recommendation. It is from their cookbooks. I don't know. But anyhow, these IOL images, I'm running 19 of them. I highlighted the entire topology, and clicked start, and my CPU never went above 5%. Okay. Now, if I drag just one VIOS image on here and click start, it'll send the CPU spiraling around to 99%. So that's making me think that maybe I need to rethink how I build and how I prepare for the CCIE as far as making my own labs. If I'm building my own labs, I should probably be doing them with the IOL images. And I think the only reason is just efficiency. Okay, just efficiency. So another person out there in the world had made the INE topology, the physical layout in EVE-NG, and I've been using that as my foundation. And I have the workbook, so I just put the initial configs in for each one. But they made the topology, and they made the topology as well as adjusted some of the initial configs to fit the naming convention, the interface naming convention of the VIOS, which uses gigabit interfaces. If you'll notice here, all of these interfaces are Ethernet interfaces. They're not gigabit, they're straight up Ethernet interfaces. So that would mean if I want to use IOL images, I'm going to have to find an automated way to convert a lot of topologies that reference gigabit interfaces to Ethernet interfaces, which you would think should be something that's like a find and replace, but man, I have found that there can always be something you miss and you end up troubleshooting the wrong thing for a long time. So anyhow, I'm really impressed with the efficiency of IOL running 19 routers. Using VIOS, I struggle to run the INE foundation topology. That is, if I try to run them all at one time. When I have them all running and they're cruising along and they're just humming the INE topology using VIOS images, it runs at about 25%. My CPU is about 25%, maybe 40%, maybe 50%. Kind of depends on the day. But this is running a cool 5%, man. Cool. Ooh, man, this is nice. Lightweight. Okay. So I wanted to share that with you guys. The next thing, I kind of wanted to talk about something that I did today that is a little bit out of the scope, I think, for sort of most network engineers. But I'm very fortunate that I have the opportunity to do these sort of things a little bit. So I did a little bit of sort of cyber forensics, or I guess network forensics, and a little bit of investigation, digging deep into some PCAPs on a couple of things. And so it's kind of cool. So I get to I get some alerts from a system at work. So at work we have a corporate network. We also have a sort of a lab network, and a lab network is a place where some of us engineers can stand up certain projects, and we get to, I don't know, I call it play around a little bit. Really is, we're learning and growing and building cool things, cool systems. But when you do what you love, it's just playing. So we just get to play a little bit. And there are a number of systems I've set up to sort of watch traffic on the wire and extrapolate data and a whole bunch of stuff. And so we set up an alerting system recently that sends some alerts to a private Slack group, and I was surprised at some of the alerts I was getting and what they were going to. So I went into the office today, and I started looking at it, and I started pulling PCAPs. And I did that for a while. I used a lot of NetFlow. We got a robust NetFlow system. I'm partial to NTOP-NG. Man, if anyone wants a great free open source, it's certainly free. On any Ubuntu or Debian distro, you can just do apt install and NTOP-NG, and you have yourself NetFlow up and running, no problem. And a number of other tools. So I was able to pull a PCAP, use NetFlow to be able to find the destination and target hosts I was looking at. I was able to correlate some IP lookup information and get those pulls, some geolocations to find out where in the world these things are coming from. There was a certain pattern to the way that I was seeing these, from the alerts that I was getting, that I was seeing these connections being made. So I pulled a PCAP for about an hour or so, isolating only out of all the traffic that we have. And we had about 40 gigabytes worth of traffic today. I think we average about 40 gigabytes worth of traffic in one day in and out of our lab. I isolated on just 2 single IPs, and then I was able to run that through Bro. And through that, that leads to an even deeper investigation, right? Because that goes ahead and analyzes your entire PCAP and starts pulling out all the different things: the SSL log, the HTTP log, the connection log, the DNS log, the X509 log, the weird log, and even more if it sees that, the files log. And it was really interesting to see the breakdown of all of the traffic going to maybe these 2 IPs that was generating a lot of alarms for me, and being able to sort of figure out what is valid communication and what do we need to start looking at. And it was pretty interesting. I got to see some connections. There are some attempts being made to connect to a mail server, and I got to see, you know, SMTP is a clear text protocol, so you get to see the commands that are being run right in the PCAP. It's really cool stuff. I get to correlate that information against some open source. I'm trying to think, cloud databases of known command and control IPs and known malware hosts and known malware domains, and sort of correlate that data and figure out, you know, where we are in the spam house list, or in the the DShield list, and all these other lists out there, which list, you know, sort of dynamically list IPs that have I'm trying to think, a high probability that they should be blocked, that they're probably doing bad things. And these IPs change, right? IPs are cheap. You can get a new IP, no problem. So IPs change, so you need to make sure that whatever blocks you put in place can be changed as well, and can sort of follow. So I went ahead and configured our firewall to dynamically pull some of these IP lists just to help block some of the obvious ones, right? Because that's how I got the alerts, was these IP addresses were already on a blacklist. And so I made sure that those blacklists are then directly fed into our firewall, and that we can go ahead and just start blocking right on the edge, right? So they don't even come into the network. And then it'll generate some new logs into a new log group. So I'll get to see when these blacklist IPs get dropped to the firewall. So that's pretty cool. You know, and again, this isn't necessarily what I do for work, but it is what I did for work. And it was very cool. And through that, I was able to show a couple of coworkers and turn it into a teachable moment, right? So I'm always looking at everything from sort of the networking perspective, and you know, I like to say that I'm the networking guy who works for a security company, but really I got into networking because of my interest in network security. So that's where my heart lies. So that was pretty cool. I don't think not every day do most network engineers get the opportunity to do something like that. And I'm very fortunate and grateful that I do get to do something like that, and be able to turn it into something that's teachable for other people, and that we can actually use to show examples, you know, to other engineers and other cybersecurity experts, to be able to share sort of the systems that we built and how we correlate information and stuff like that, and get to work together. So it's really cool. And that's what I got to do today for a little while. And I absolutely love the sort of network forensics investigation work. I love just getting down to every bit in a packet until you understand every flow. And I don't know why, but that's just who I am. It's like you can't walk away from a topology that's broken, you know, like a network engineer can't walk away from a topology lab that's broken or something. And like I can't walk away from a PCAP until I see everything that is inside of it. So it's a lot of fun. So if anyone out there wants to get into network security, stuff like that, there's a lot of free and open source tools. I'm kind of just like saying everything that has been said a million times on the internet already about free and open source and network security and stuff. I'm actually hoping that maybe after I take my time and work through my CCIE, that I can go back and continue to do streaming, but probably open the doors up to some of the security stuff that I deal with on a regular basis, and kind of show you guys some of the systems that I work with, because I think they're pretty cool, and there's a lot to gain from it. There's a lot to gain for network engineers to understand the security systems, and I think that's where I have personally and professionally a little bit of advantage over your average network engineer. when you're comparing apples to apples. So, guys, I think that about wraps it up. I had an awesome time working the OSPF topology from Nick Russo. Thank you very much. This is a wrap-up of day 25, so we're a quarter of the way through our journey. I'm absolutely frightened out of my mind thinking that 25% of my time is already spent, and knowing that the next 75 days is going to just go like that. So I'm absolutely frightened. But I look back on what I've done in the past 25 days, and I have accomplished a lot. It's a lot to put on this stream. It's a lot to try and make it efficient. It's a lot to make it not be a burden on everything that I do. It's a lot to try and generate content and build labs and share that out with the community and participate in our Discord server and on Twitter and all the different Slack groups. And those all have their benefits, but they also take away a little bit of time, and time is so precious in this game. So I just want to thank everybody for spending the last 25 days with me. And if you guys are out there labbing at home, I want to thank you for continuing to do your labs and put forth the effort and stay focused. You know, I hope, if nothing else, if I'm not teaching anyone anything, any technical skill or explaining anything in a way that isn't helpful at all, I hope at least I'm providing motivation to keep going, motivation to keep pumping along. If it wasn't for this stream, I probably would have given up, and maybe not given up, but taken a lot more breaks and not been as consistent. So this is keeping me honest, and I'm going to keep it up for absolutely as long as I can. So thank you all, and I will see you all tomorrow. I might do something else because I think I'm getting burned out on OSPF database. I think I need to give it a rest and then come back and see what I've really retained, see what I really understand. And I don't know what I'll do tomorrow if I don't do OSPF. I don't know what I'll do. If any of you have recommendations, you can find me on the Discord server. The link is below in the video description. You can join the Discord server and reach me in the 100 Days of Labbing channel. There you can give me some recommendations on what you'd like me to see me do next. All right. See ya.